this
now.
meeting to order.
All righty.
We're live.
All right. Thank you very much, everybody, for joining us on a windy March night. This is, if you've joined us for the first time, the Warren Astronomical Society, having our customary Monday meeting live on the internet instead of at Cranbrook Institute of Science like we used to. I am President Diane Hall, and we will kick things off with the officer reports as your president. The board is taking the potential reopening of our meeting spaces very seriously. We have decided to convene an off-site meeting. So instead of the normal board meeting with an hour-long time limit, we're going to be doing an off-site meeting to discuss things as thoroughly as possible in terms of our two different meeting rooms at Cranbrook and Macomb, what their current requirements are, if we can meet those current requirements in the event that we go back, how we're going to handle snacks, how we're going to handle the visuals, what we're going to broadcast, if we're going to keep on doing some kind of live webcast, or if we're going to go back to simply having things filmed and edited and uploaded after the fact. So we've got a lot of factors. If you have a question that you feel the board needs to answer before making a decision, please send it to board@warrenastro.org. Otherwise, with the seven of us have had a lot of discussions over the months, so we've already thought of a lot of things, like snacks, like discussion groups, etc. But if there's anything that you do want us to consider when we have this offsite meeting, which is probably going to be this upcoming weekend, get that into us so that we can make our decision with all the information available and see what we can do to phase in-person meetings. Or not, as every time we've been on the verge of doing that, we've had a spike in COVID. Fingers crossed that doesn't happen again. Okay, so that's the big thing on our presidential plate. We've got some other developments regarding the bequest left to us by late member John Root, which Adrian and Mark are sorting out with the insurance company. Or rather, Mark got the documents from the insurance company. Adrian is sorting that out with them. So that is, again, very, very kind of him to think of us. And we are curious to find out what the bequest consists of and what we should best do to honor it. So with that, I'll pass things over to First Vice President Bob Tremblay.
Hi, everyone. I have been. I don't know if Dale Parton panicked in this position, but I'm starting to panic. I need some speakers for April and further on. I did get one interesting person to agree to talk to us. Bob Nemiroff from the Astronomy Picture of the Day is going to be talking to us in the fall about a new book he's writing. So, yeah, go me. If any of our club members would like to give a discussion about a topic on astronomy and space science, please give me an email and we'll get you scheduled. And in my talk tonight, I'm going to be covering several things which could be a full discussion. So that's it.
Well, first vice presidents have always had good luck arm twisting at actual meetings, so that is one thing to potentially look forward to if we resume at Cranbrook in particular.
Well, so, our membership, if anybody wants, the first time I gave a presentation, I was terrified. And if that's what is stopping people from, giving presentations and stuff, or maybe it's the time it takes to make them, but, I'm not terrified anymore. That goes away. And it's really a great way. If you're interested in something, making a presentation is a great way to research it too. So I would encourage everybody to go ahead and make a presentation.
Short presentations count. 10 minutes. 10 minutes talking about your favorite cloud formations totally counts.
Well, I'm definitely interested, Bob. I could talk about the fun and games of being stuck in Sheboygan trying to drive a little too far into a field to image something, and it was cloudy.
You're writing a book too.
Yeah, I am. So I'd be happy to talk about that book too. So If you want to put me down for a couple, the short presentations, I think that would work well.
All right, sort that out of break, y'all, but that is progress. Again, short presentations are presentations, and we love to hear from y'all. With that, over to Riyadh at Second VP Observatory Stuff.
Thank you, Diane. Hello, everyone. We had our last open house on February 26th. Actually, because I couldn't go to the observatory, Doug Bock volunteered to have a virtual open house through Northern Cross Observatory. And basically, Doug started out by showing us images that he took of the sun with his 6-inch Schmidt-Cassegrain. And then later on, went through some explanations on how his equipment work. And also, we had some observing of some objects. It was clear that night. In addition to hosting the virtual open house, Doug later on also included a report in the WASP with the photographs that he took through his telescope. So if you get a chance, if you're not at the virtual open house, please take a look at the WASP. You can see those images that he took. The next open house is going to be on March 26th, and hopefully that will be in person. I think Jeff McLeod has volunteered to have that open house. So hopefully you'll be out there, and I'm hoping that we will have clear sky. So that's all I have at this time. Thank you, Diane.
Thank you, Riyadh. And people interested again in joining Riyadh and being qualified to open the observatory dome, please let him know. It's not as threatening as it sounds to deal with the dome, and it can be very rewarding. And then you're qualified to do it on your own for your own fun. So, there's benefits. Okay, over to recording secretary Mark Kedzier.
Thank you, Madam President. The minutes are in the WASP, and that's all I have to report.
Short and sweet. All right, over to Adrian at Treasury.
Hopefully mine will be short and sweet as well. My report is also in the WASP. We're sitting on around $22,000 in our treasury. The GLAC has established a 501c3 status, and we voted as a board to transfer the money to the GLAC account. So I'll be handling that. And you also heard that I'll be handling the John Root, the inheritance that John has left for us as the Warren Astronomical Society. So I'll be taking care of those couple pieces of paperwork. And I do have the cash box and donations PayPal swiper thing that once we get back to being in person, we will be able to accept donations, card cash, or whatever you've got on site. But let's get to on site first before we worry about that. And with that, that's my report.
Did you mention the big treasury news?
The GLAC.
Yeah.
The GLAC treasury. Yeah, I glossed through it. I said we're going to transfer the funds to GLAC's own account. They have established a 501c3 status. I might have forgotten to say that.
Just wanted to emphasize that is actually a very big achievement of both the GLAC board in getting 501c3 status, of Adrian as treasurer of both organizations, and something I'm very happy to see happen on my watch, because as a former president of GLAC, that is something that we've wanted for GLAC the whole time. The WASP being the custodian of GLAC funds was always meant to be a short-term measure, a stopgap. And so to be able to transfer the funds back to GLAC is such a good feeling, and kudos to everybody involved. So thank y'all.
Yep, John. Your Vice President Bob Trembley's a part of it. John Wallbank is the president of GLAC, and he established he's got some relationships with folks who helped him achieve that status. So Much kudos to him and I'm the treasurer for both organizations, so it makes brokering that transition pretty easy. I talk to myself, and together myself make it happen. So with that, I don't have anything else pressing. So that's the end of my report.
Thank you, Adrian, and that is just such good news. All right, over to Kevin at Outreach.
I just have one thing. Mark Kedzier is running an outreach on March 10th as part of the NASA My Library grant that they received in 2021. It's in the news. It's in the newsletter if you want more information about it.
And it's a bit early yet, but we also do have Swan Night coming up on April 8th. So that is the statewide astronomy night, and we'll have a more detailed pitch as the date approaches.
Okay.
If you have anything going on that you'd like to be highlighted in Kevin's outreach report, email the board so we can get it in. Don't shout it out right now. We want it in writing so we can, read it. Okay, very good. And then over to Dale Teamy at Award-Winning Publications Desk.
Oh, continuing the policy of short reports, I want to report that the WASP is up and online for the month of, what is it now?
It's March.
March.
Isn't that
Okay. We're there.
We're there. Okay, very good. With that, we will barrel along to the subgroups. Solar subgroup. I don't see Captain Marty, who celebrated his birthday yesterday. Maybe that was one heck of a party. Bob, could you throw those SDO images up in the chat? Oh, even better. Nice.
What we're seeing here, this is ultraviolet image of the sun. The kind of like what you'd see through a solar telescope, but we got a lot of prominences on the lower right there. We've got one that just stays for days. On the upper left, we've got a loop prominence which comes in and lasts for probably only a couple hours right there. And that active region near the equator is just flaring like crazy. Actually, there's a couple of them that are flaring like crazy. And let's see, let's go over to the other one here. Oh, for crying out loud. There we go. This is the corona.
Wow.
You're seeing a lot of corona loops. Yeah, there's a whole lot of activity. If you have a solar telescope, it would be the time to get it out right now. There's just you're not that you're going to see this, but yeah, there's just a whole lot of activity. That's just beautiful. And this is from the SOHO. That is the solar corona, and you'll see a coronal mass ejection there. This is the disk of the sun is that white circle, and there's an obscuring disk that's blocking the brightness, so you're seeing all of the flows of the solar wind coming out there. So that's pretty cool. So that's the sun for the last couple days.
Very exciting. All right, double star group. What have we got, Riyadh?
Yeah, Diane, thank you. As I mentioned, I think it was the last meeting, I'm working on getting some equipment to do some actual hands-on work at the observatory besides observing. So we already have a micrometer eyepiece that we can use for measuring double stars, as well as we're working on getting possibly a spectrometer for us, and eventually a digital camera. Actually, Adrian has donated a digital camera to us right now. It's called the Revolution Imager. That we're going to try to start to work with that first, and later on, eventually, we may get a camera with a larger chip to do some work. So I'm looking forward to that. Hopefully, we're going to have some actual hands-on work to do. Like I said, besides actually looking at double stars and planets and looking at the moon as well. So we can do some more work besides observing, like I said. So thank you.
Thank you, Riyadh. Getting scientific grade equipment to go with a research grade Andy Kula mount. to maximize the potential of what the Kalinowski-Kula telescope is capable of. Fabulous. Over to history subgroup.
Okay, I do have news. I revisited Jim Shlodowski's collection of newsletters that he donated, and it turns out that the newsletters in his binders aren't necessarily in chronological order. So I actually discovered a new issue that we don't have the digital collection. So that's May 1990. And it came from a second perusal of the Jim Shlodowski collection. I'm tempted to do a third. And I will
Fabulous.
post a link to that issue in the chat. And here's something that I wanted. I don't know why I didn't think of this before. When I'm looking through the issues to putting together the History SIG report and the WASP, I'm looking at back issues and coming up with something to say about each one. And I never say anything about the meeting notes, which actually records what we've been up to in those years. So I'm going to try something new here. For tonight, I'm going to do 10 years ago and 20 years ago. And then the next meeting, I will do 30 and 40 years ago. So 10 years ago, I noticed that I started my career on the WAS board with a 2-year break of 8 years and counting. I've been on the board a long time. And in that issue, the main talk at Cranbrook was the day the USSR lost the moon race by Dan Hall. And I remember that talk very well. And I also found that Gary Ross was doing observing ports in the WASP back then. And here I thought he just recently started doing that. So I learned something new. Now, 20 years ago, if it weren't for Larry Kalinowski, we wouldn't even have a record of this period, because all that was in the WASP was his Astro chatter and that sort of thing, and no meeting minutes. So along with this mix of computer and astronomy news, we get a progress report on the effects of the ATM group. 3 more telescopes have been completed because of the WASP Pass mirror making group. Thanks to Steve Green, who is helping to put those mirrors into useful operation, they've successfully launched Don Lemon's 6-inch telescope, Bob Watt's mirrors into useful operation. Oh, no, Bob Watt's 12.5-inch, and then Blaine McCullough's 13-inch scope into operational instruments. He goes on to say, Roger Civic, an older member, past newsletter editor, yay, and designer of the club logo, standing ovation, stopped in at the Cranbrook meeting on February 4th to say hello and tempt some of us out of our pocket change by displaying a bunch of astronomical hardware during the meeting. Finally, Larry knows that this was the start of his 11th year of pounding the keys for the WASP. I can relate. My involvement with the WASP started in 2011 when the scanning project began with Jonathan Cade looking for volunteers to scan the old WASP, and we all know how that turned out. Thank you, Diane.
Love it. Love a trip down memory lane. All right. Let's see. I don't see the new chair of our radio group tonight. So just a reminder that we have reestablished the radio group under the leadership of Tom, formerly with the McMath-Hulbert Radio Astronomy Club. The McMath-Hulbert gang no longer has access to their site, so some of them have set up shop with us instead, and we're looking forward to them, being able to do some radio astronomy out at Stargate. Let's see. Any other special interest groups? I thought I saw Bill. Well, there's Doug. Doug, what have we got from the Astrophotography Club?
Well, my talk tonight is going to be a little bit about that beginning astronomy and some advanced astro imaging and some advanced astro imaging. So we'll just leave it at that. Other than the fact that the sun has been kind of fun and active, and I've been getting my 6-inch SET out and doing a little bit of solar work with a white filter.
Boy, is that an understatement.
Sounds good.
David, you're saying that's an understatement. The sun has been kind of
Oh
active.
yeah, the sun has been just rumping. the last few days.
So I've got a little bit of a astrophotography for those that like to do what's called landscape astrophotography. Some of them have been getting up in the morning because they consider Milky Way season as the time when you can see the core of the Milky Way and you can image it. So a lot of Milky Way shots will look familiar. We'll have the core rising flat, angled up in the northern hemisphere. The southern hemisphere is transitioning from summer into winter, where when they're in the thick of winter, the Milky Way will rise high above their heads, and some of the best southern hemisphere imaging of the Milky Way occurs. And meanwhile, we continue to image the core. I consider Milky Way season year round because the Orion side to me is just as interesting, and the Cygnus side as well. Most imagers wait and pull out the cameras during spring and summer. I, however, shoot year round. So that'll be my report on landscape astrophotography.
All right, thank y'all. And any other special interest group captains out there? Hopefully, at some point this year, we'll start having reports from the discussion group captain again. Okay, let's transition over to observing reports. I see 2 hands up from our colleague down in the desert of the Southwest. Take it away, Dr. Levy.
Well, thank you. Thank you very, very much. The sun, as I just mentioned a few seconds ago, is very active these days. It is so active that the one of the websites that predicted a mild to less than active cycle has now changed their prediction. That this cycle is going to be very, very strong. And that's kind of like predicting a snowstorm after the snowstorm has come. I don't know what they use to make their predictions, but I like to think the sun will do what the sun will do. This morning, after a sleepless night, I went outside to do some comet searching under the pre-dawn sky for the first time in a long time. It was a lot of fun. And for my quotation of this meeting, I'd like to discuss an observing session held by the main character of Jane Eyre, Charlotte Bronte's masterpiece, Jane herself. He had just finished. I think that Charlotte Bronte is possibly the greatest writer after Shakespeare. Anyway, she had just finished spooking. She had just finished spooking Rochester's horse, giving Rochester a sprained ankle, and she's on her way back to Thornfield. And she says, I lingered at the gates. I lingered on the lawn. I paced backwards and forwards on the pavement. The shutters were closed. I could not see into the interior. My eyes and spirit were drawn from the gloomy house. From the gloomy house to that sky expanded before me, a blue sea absolved from taint of cloud, the moon ascending it in solemn march, her orb seeming to look up as she left the hilltops, from behind which she had come, far and farther below her, and aspired to the zenith, midnight dark in its fathomless depth and measureless distance. And for those trembling stars that followed her course, they made my heart tremble, my veins glow when I viewed them. Little things recall us to earth. The clock struck in the hall. I turned from the moon and the stars, opened a side door, and went in. Thank you very much. And back to you, Diane.
Thank you, Dr. Levy. I do love that book. All right, observing reports. Raise your hand.
My hand is virtually raised.
All right, Adrian.
So really quickly, one of my targets lately is to catch the night sky at the very beginning of Astronomical Twilight. I was able to see this when I went to Port Sanilac overlooking Lake Huron. And maybe later I'll share the image. I won't share it now. But when you image the sky, you get, instead of your blue, black, or gray background sky, you get this sky blue. But all of those deep sky objects are still, the deep sky objects remain. You can still see the Milky Way. It's a very interesting color palette, both visually and when you snap the picture. You have about 5 minutes to see this. And then afterwards, the Milky Way and all the stars get washed away. And all you're left with are the absolute brightest stars and planets. And then from there, an hour to an hour and a half, the disk of the sun cracks the horizon. So if you've heard the term crack of dawn, something that we may take for granted, most of the time, civil dawn is what we think of crack of dawn, but the true very first moment is astronomical twilight. So it is, that's what I've been looking at, and that's what I'm hoping to catch early tomorrow morning. That's my observing report.
All right, thank you. Anybody else? I know the weather has been iffy lately. Doug Bock.
Thank you, Diane. I'm going to go over quickly the open house results that we had on the 26th. And let me just share that. So that night we used the 4-inch refractor, and these are just some of the results that we took out. For example, this is IC 410, which is a nebula with a star cluster in the middle of it. And this is basically 40 minutes of data. Then we worked on the Leo triplet, which I will also with the same scope. And this is approximately 5 hours of data from the 27th, the morning of the 27th. This is M66, M65, and this is NGC 20, I think it's 2158. And that's the actual field of view, and the previous one was cropped a little bit. And of course, this was the plate solve of that area, with including a asteroid Palatia right here that was captured. And then we went on to M35, which is a nice open cluster here with NGC 2158 here. Actually, that was 2158 in Gemini. This is the raw data that was taken. And by the way, the plate solves are done within a tool called PixInsight. It allows me to plate solve like this.
Those are beautiful colors, Doug.
There's a lot of stars in that cluster.
They look violet.
Yep. It's a pretty cluster, and what's cool is the difference in this background cluster near it in terms of the color. We went after M97, M108. This was the plate solve with all those PGC galaxies in that field of view, but this is what the two Messier objects plus the one NGC that's identified. And this is the raw data. Again, this is with the 4-inch refractor.
Doug, as I recall, Stephen Agus was your plate solver until you started using PixInsight. Is this true?
I don't recall that.
You mentioned at some point Steve Agus would see your
what he did was he pulled out, he went back and now I had plate solve these images all along, but what he did was he took out one of my images that I had, and he hunted for a quasar that was in my image, and he identified that. That's what he did. Quasar is approximately 11 billion light years away, so that was interesting. Okay. This is the Mercurian's chain area, Virgo cluster group, and again, there's all these NGC galaxies and PGC galaxies in there, but this is without the PGCs, and then this is the raw data I took with the 4-inch. So here's the Mercurian chain that you'd see that I could. I really enjoy this. This is M86 right here. I remember going in 1996 down to Texas Star Party with my 20-inch for the first time, and I was able to, with my 27 Panoptic, be able to get all of this area here in one field of view, and it was just fantastic down there. So that was kind of fun. Let's see what else we got. Oh, this was the star cluster 2246 in the middle of the Rosette Nebula. This is 13 times 3 minutes. It's not one of my best rosettes, but it was what we did that night. This is called the Cone Nebula, which has a lot of blue here. The cone's down here in this section here. But what I found interesting was not only the H alpha, but also the reflection nebula was sitting here in this field of view. Was kind of nice, kind of cool.
Beautiful.
And that is what's in the newsletter is this conglomerate of those objects. There we go. That's what I have in the newsletter. Okay, so that's my report from last open house a week or so ago.
Very cool.
I did do some solar work, which I'm going to go over a little bit in my presentation.
All right, who's next? Ken, is that your hand up?
Yep.
All right, take it away.
Just a simple thing for those people that are not into the heavy duty photography and so on and so forth. The other night, I went to do some officiating, and outside was a young man who probably will join our club. Had a very, very nice equipment set up, and he was looking into the. I'm trying to remember which nebula he was doing, but what was remarkable was the winter circle was pretty darn spectacular. For those of you who are just observers and go out there and look at the alphabetical order around of Aldebaran, Castor, and Capella, Castor, Pollux, and Procyon and Sirius, and then out of sequence is Rigel, and right in the middle of the whole thing is Betelgeuse. And it was very, very remarkable that night. It was very nice, dark skies, very clear, and several of the other people that were at the volleyball came out to watch the stuff that he was doing, which was pretty remarkable. And it was very nice. And I try to recruit him for our club. But just for an observation, go out there just after sunset, and look out there to the west, and you will get to see a very, very nice display. And if you just are very attentive, look at the Big Dipper, take a look at the handle wrapping around to Arcturus that is now just rising, which is the brightest star in the summer sky, as they say. Anyway, I just said that without all the photography involved, but just the same. Those of you who are not into photography at this point in time, just go out there and observe some of the beautiful things we have out there. That's all I have for observing.
All right, thank you, Ken. Anybody else?
Is there time for me to, I've come to a stop. Is there time for me to share a couple of images?
Yeah, there is actually. Take it away.
Okay, there are two images that I will share out of my photo bucket. The first image highlights what I was talking about by Astronomical Twilight. So that bluish sky, yet you can see all of the stars and even the nebulae in the Cygnus region of the Milky Way. That period of time happens for around 5 to 7 minutes after the first light cracks above the horizon. And that's Lake Huron. We're facing Canada. So a direct shot east. That Milky Way disappears within 5 minutes. It's, if you watch it, it just gets fainter and fainter with each second. Also, what Ken was talking about. Oh, and part of the reason I'm trying to make a trip, I'll share this image. So the Milky Way core is visible in the morning. This image highlights what happened to me and why I'm trying to make another trip to go see it, because half that was cloudy is obscuring the core. I've got some images where you can see the core and you can see the scorpion, but unfortunately, as beautiful a picture as it is, there's my target was the galactic center, which is being shrouded from view. Still, it's a beautiful part of the day. If you get up early enough to see it, definitely go and see it. And now I will share this image. Well, there's a couple. So Ken was talking about Orion. With 6 minutes of data tracking at a dark sky park, and a little bit of haze in the sky, I ended up with this image of the belt and sword region of Orion.
Magnificent.
And this popped out. So now, I of course made the mistake of blowing away the core. There are techniques you can do to make Orion look a lot better, and a lot of good astrophotographers will get detail in this area. But the darker the skies, the easier it is to get real data. And also be on the lookout for the Zodiacal Light. The Zodiacal Light is back. Couple of phenomena are back. Let me
Yes, this is
demonstrate.
peak time for Zodiacal Light in the evening.
Yes, so there it is. That's what it looks like. There's a conical bit of light coming from where the sun set. In the spring, it emanates from where the sun sets. And you can see it aiming up here because I have the wide angle lens, so it kind of curved the outsides. It is going through the Pleiades. There's the Pleiades, there's the Hyades, and there's Orion. So if you're looking for it in the evening, find the winter hexagon that Ken Burton talked about, and then go to the right till you get to the Pleiades. Look up and down. It's a fainter glow right now. It's getting brighter and brighter. I took this maybe a week or two ago. The winter Milky Way is over here, and the image that Doug had, I thought I would have it here, but it's not showing up very well.
It can actually
In
be
the
extremely annoying in a dark sky site.
Yeah,
We were in Jonathan and I were at Mauna Kea in March back in 2008, and the Zodiacal Light was so bright it looked like the moon was about to come up. It faded
yes.
thankfully, but it was very, very annoying.
Light pillars are still happening. This is north. Light pillars, when it gets cold enough at night and there's ice crystals in the air, man-made light gets shot up into the atmosphere in a column. That's what you're seeing here. This was the saving grace of a trip gone wrong, where the skies were cloudy most of the time when I traveled up. So I got out, took that shot really quickly. So this phenomena is pretty it's been consistent. There have been a lot of pictures people have taken lately of light pillars, depending on where they are and how far they are from the light sources. Different color lights end up going into the night sky. I didn't get the different colors here. And really quickly, this is the last share. This isn't the illegal ball that I own. I found that I own an illegal ball now. That's always cool to know. So the Zodiacal Light is usually, see if I can find it here. The Zodiacal Light is usually a hindrance in viewing. It can get really, really bright. But if I'm lucky enough, I have a picture somewhere that I can share that shows the zodiacal light, how you can use it to create an artistic effect. And it is not showing up fast enough in my I'll cancel it if I can't find it. Now here we go. That's one way you can, that the zodiacal light is actually cool to look at. In the fall, it points the other way.
Yep.
This is before sunrise, and Orion is rising, and there's your bright zodiacal light. There's your beehive cluster right here. Didn't render out too good, but that's M44, and there's Orion. So interesting fact is whenever the zodiacal light is visible, Orion is involved somewhere in the process. It's nearby. It's either coming from one angle towards it or the other. Orion is close to the ecliptic, so that explains why Orion is usually near where the zodiacal light will show up. This is the rosette. That small little blotch in my picture was the picture that Doug showed you the cluster from, and a little more detail. He's got a few Rosette Nebula shots that he's done, and that's where the rosette is in relation to Orion. If you're looking up at the night sky, you may not see all of this hydrogen alpha data or any of that, but you will see a faint wisp of the Milky Way. You'll see the stars that make up Orion. Where Doug was aiming, you look left, you might see, if it's dark enough, you might see a group of stars immediately to Orion's left. And some of the stars that Ken was talking about, Sirius, over here, Procyon, Pollux Castor. I don't think I quite caught Capella in this shot. Capella's been chopped up. I think it's above where everything is. So, at any rate, that is all I will share.
Cool.
I've kept
Thank-
busy and
Thank you,
hoping to get
Adrian.
more
You'll
later.
want to have a look at the chat if you get a chance, because you've got some fan mail there from one of our participants tonight, John, who is praising you for cool photos and how easy you make it look, which, as somebody who cannot take a photo worth a damn, I agree. And with
Well,
that,
I was gonna say, as you know, for fun, I'll also shoot wildlife, and I appreciate you and Jonathan, Diane, and you too, Dale, Timmy, for liking those. That's been
I
fun
dig
to
it.
do lately.
You've had some awesome shots. All
Yeah.
right,
All right.
so it's now time for our short presentation of the night. We have none other than our very own first VP, aka presentation chairperson, Robert Tremblay, on deck. For those of you who've new to the club, you probably have seen that Bob is carries a lot of balls for us, or batons for us, doing the first VP duties. He does the solar subgroup, and he's a space mission enthusiast, a solar system ambassador, is a professional in the astronomical world, and that he does IT and social media work for the Vatican Observatory, and has some very cool Michigan tech stories about both stargazing and missile range shenanigans. So everybody give it up for Bob, who's going to talk to us about one of the coolest space missions that hasn't quite happened yet. Take it away, Bob.
Right. Everybody see the intro screen here.
Yep.
All right,
Yes.
cool. Okay. This intro screen, by the way, is available at that website as a desktop background and as a printable poster. And it's also what was on the cover of Sky and Telescope recently. So, Europa, where is my meeting notes? Hold on. Good heavens. Well, I don't need these. Europa, a icy moon of Jupiter. attempt no landings here. It is the second moon out from Jupiter of the 4 Galilean moons. Because it orbits so close to Jupiter, it experiences a lot of tidal shearing as it orbits. Essentially, what that does is the moon, uh, the moon deforms a little bit, just a little bit, but we're talking about a moon, so that little bit of deformation can create a lot of energy internally, and that energy wants to radiate upwards. And so what they think's going on is that Europa, along with several of the bodies in the outer solar system, has a subsurface ocean and underneath its icy crust. And what we've got going on here is this heat radiating up out of the planet. You're going to have volcanism, and you're going to have very, very deep, probably salty oceans. We're talking like 60 kilometers deep, which would be interesting because the moon has less gravity, so 60 kilometers pressure probably would be pretty great. Interesting stuff going on that deep down. So here is the idea. You've got this deep ocean and a crust of ice on top. This hot plumes from these volcanoes and on the surface under the water can create plumes which can carry up materials. Well, now let's talk about a previous mission. I think my favorite mission is the Cassini mission at Saturn. When it got there, it discovered these plumes coming out of Saturn's moon Enceladus, and they weren't expecting that, and so they flew by them and analyzed them, and eventually they flew right through them and analyzed them with everything Cassini had, and they found some very interesting things, including organic compounds and salts and silica. And what they think's going on here is there's hydrothermal vents from this tidal shearing. Now these things are these are hydrothermal vents on the floor of the Earth's oceans. If you didn't know these existed, and I've talked to several people recently who did not know these existed, go look them up. They're very cool. The interesting thing about these things is, they're very deep down. It's very cold. These things are blasting out ridiculously hot water, and they support diverse ecosystems that are unlike anything that we're familiar with up here. These things metabolize hydrogen sulfide, and they can live in the ridiculous variances of hot and cold by these things. So here's an example. These are tube worms, very happy in very, very, very hot water. And those things, I actually saw a picture. These things are about as tall as humans. So as a famous actor who played a scientist once said, life finds a way. And on Earth here, we've got bacteria that live in ice, and we've got bacteria that live in boiling hot. What are these things? I forget what that called, but anyway, so there's life in these things. So when they detected plumes coming from Europa in 2012, that pretty much sealed it. So the Europa Clipper mission is due to launch in 2024. It's an orbiter mission. It will be orbiting Jupiter, and it will be flying by Europa several times. It's going to conduct a detailed reconnaissance of Europa and whether it could harbor conditions suitable for life. Now, it's hard to believe that an ice moon way out by Jupiter could be suitable for life, but we're going to be looking for it. So here's some of the instruments on it. It's got a lot of the things you would expect, mass spectrometer, being able to, cameras, visible, ultraviolet, infrared. The interesting thing it's got here is ice penetrating radar, which is going to be very interesting to see. All these instruments are packed very tightly onto onto the spacecraft. Um, I think it is a form of art in itself, being able to design a spacecraft and get all this stuff packed together and working together. That is just amazing. So It was due to launch actually on the SLS, but in 2021 that was canceled, and it's going on a Falcon Heavy. The SLS would have been able to push it directly to Jupiter. Now with Falcon Heavy, we got to go a couple gravity assists by Mars and Earth, and it's going to arrive at Jupiter in 2030. And I posted a tweet this morning. I said, you know, I was born at the beginning of the space age, and here I am writing this presentation about the Europa Clipper, and I'm seeing it's not getting there till 2030, and I'm like, man, I want the entire solar system to be explored now, darn it, and I'm not going to get that, which is kind of upsetting. So anyway, it's going to be flying by Europa 44 times above, below, and beside several different ways. It's going to be mapping this thing entirely for 3.5 years. And it's going to be sharing it's going to be sharing data with NASA's or ESA's JUICE mission, which is going to be looking at some of the other moons in the Jupiter system. So I've learned from a solar system ambassador who is now on the Europa Clipper team. I asked what are they planning to do with it at the end of mission, and the plan is to plow it into Ganymede. And the thing I find interesting about that is the reason they're doing that is because there could be life on Europa. They want to protect that, but they've just found out there's probably a subsurface ocean on Ganymede. So I'm not sure if they want to reconsider that. So I'm going to be giving a demonstration of the Europa Clipper mission that is in NASA's Eyes on the Solar System. This is an installable app for the PC and Mac. I've been using it for years. I use it every week in my posts. There is a web-based version that you don't have to install if you have any device on the planet that has access to the internet. You can run this thing, and all of the modules that are in the app, you can do Eyes on the Earth, which has environmental data, solar system, and exoplanets. They've all been developed into a web-based version. So let me bring this thing over here, and see. Are you seeing the solar system now, or is it still showing the?
Yeah, I see the solar system.
Okay,
Top down.
this is okay. This is the NASA Eyes app. It says, and it works like it's got a game engine interface. You can scroll and that kind of stuff. And it says, I bring this up every week, and I saw the DART mission hanging out there, and I'm like, this was brand new. This was they put this in the application a couple weeks ago. And I'm like, oh, I'm going to time accelerate and see where that thing's going, expecting to see Didymus there, which I don't see Didymus there. So let's time accelerate a little bit here. And there it's going, time accelerate, and then all of a sudden, I see, come on, there it is, the Europa Clipper pop out. And I'm like, what on earth is that doing there in 2022? Because it's not due to launch until 2024. So I contacted the guys about that. So I think what this is this is the launch trajectory of when they were planning on doing it on the SLS, because it's going straight out to Jupiter. So I want to get you to Jupiter and show you what happens when it gets there. Pause it. Let's get out to Jupiter. Sorry if I'm making anybody sick by whipping the solar system around here like crazy. All right, so we got the Juno mission here. That's the around Jupiter currently. Let's whip it out. And so here's the Europa Clipper coming into Jupiter. Now, even if it does the gravity assist by the Earth and Mars, eventually when it gets out to the outer part of its orbit, it's going to look just like this. This is going to be where it's going to, the apoapsis is going to be at Jupiter, and it's going to hit Jupiter. And let's zoom in a bit here. Now, I like the way Kerbal Space Program does this better. When it gets into the sphere of influence of Jupiter, you start seeing it in an orbital frame of reference around Jupiter, but you don't. So let's go back to Jupiter now. And I whipped it way too much there. go to 2022. I just went through like 3 years there in 1 second, and that's not what I wanted to do. Let's get this back here. I swear, every time I give a live presentation, something bizarre happens.
Gary Ross would have a thing or two to say about technology.
Yeah, I know. There's the Europa
What you
Clipper.
what you might consider doing in the future is recording the demonstration and then just playing it.
So there it comes. Go slower, thank you. All right, so there it's coming into Jupiter. All right, so now it's into near Jupiter. Now this is where it gets really interesting. The first time it comes in, let's see if I can not make it whip past Jupiter. Come on. It comes into the Jupiter system. Now, when it enters Jupiter's sphere of influence, it's still going to be about a month before it gets into the Galilean moons, which is just incredible. So here, first time we're coming into Jupiter, and I didn't know what this was going to do. It flies by Ganymede and does a gravity assist. So let's go really close. So here we are. There's the Europa Clipper, and there's Ganymede. This is the first flyby, and yikes. That's really freaking close. So here's real time. Oops, and that was okay. Well, there's the live presentation thing. Gosh darn it. Okay, so it flies by Ganymede. What that does is that pulls its the outer part of its orbit, its apoapsis, and pulls it into an orbit around Jupiter. It's going to take it about a year to whip way out and come back around. This is the Juno mission did this the first time it came in, and it's going to come back around again. Anybody have a guess what it's going to do?
Is it going to swing by all the Galilean moons?
It's going to go by Ganymede again.
Oh boy.
And you'll note the outer part of its orbit there is a little smaller now, and it does this several times. It flies by Ganymede doing a gravity assist, or is it called an assist when they decrease the orbit? Should they? I think it should have a different name. But the third time it comes around, there it kind of goes by Europa. Doesn't decrease that much, and there's still, we got months and months before it comes back around again. Misses everything the fourth time around, but after like the fourth or fifth time here, we'll fly by Callisto, and there's another Ganymede flyby. Now we start decreasing this orbit quite a bit there. And I don't know how these orbital mechanics do this. This is just freaking amazing. It just keeps decreasing and decreasing until we get to the point where, come on, time accelerate. Europa, fly by Europa. Now the periapsis, the closest part to Jupiter of the orbit is right with Europa. And at this point, after it gets into this position, it flies by Europa nearly every single time it comes around. It misses it a couple times. Europa flyby, and you'll stay orbit a little shorter there, and the orbit's moving around. Europa flyby, Europa flyby. So this is just some amazing orbital mechanics. And that is how it is going to be flying by. Now, there is 250 pounds available for more stuff currently on this. And one of the some of the things they were thinking about were microsatellites, which would be really cool, a lander, but I don't know how they'd be able to do a lander with this because there is a lot of energy in that orbit right there, and you'd have to get rid of all that energy. So it would take a lot of propellant to slow that down. I'm not sure you could even do that in 250 pounds. But then again, I'm not a spacecraft designer, so that is the Europa Clippermesser in a nutshell. I mean, if anybody would like to do a presentation, more in depth on what all the instruments are doing and that kind of stuff, that would be great. But I just thought when I saw this thing flying by Ganymede and doing all of the gravity assist, this would be really, really cool to show. So any questions from anyone?
Bob, I got a question.
Yes.
So excuse me, I did step out there for a minute, so maybe you answered this, but is it planned or scheduled to do any other close flybys of
Yes.
other moons?
It's going to be flying by Ganymede very, very close several times for gravity assist. It's going to be making not gravity assist flybys, but close enough to observe of Callisto.
Okay.
So yeah, that's the data it's going to be sharing with the JUICE mission.
Are any of the other mission parameters to search for other moons, or that would just be collateral?
I'm sure that would be collateral, but if they got cameras that can do this kind of stuff, I'm sure they're going to be looking for that. You know, it would be about time to find some more moons around Jupiter because I'm sure they're going to. Now, what really interests me is this ice penetrating radar. I'd like to know more about this ice penetrating radar and how deep it's going to go, what they're expecting to find, that kind of stuff.
All right, thank you.
All right. Any other questions? Oh, thank you, Bob. I know I'm looking forward to this one. Okay, let's take a 15-minute bio break, y'all. Come back here. Actually, 8:50. We'll come back at 8:50 and have Doug Bock take us through the keynote presentation of the night, okay? So, unwind, chill, share your pictures, chat, what have you, and we'll see you at 10 till the hour.
So, Bob.
Yes, hi.
So, is this Europa Clipper definitely a go?
Yeah, it's been funded. It is in the planning stages right now, and they're in the planning stage of what launch vehicle are we going to use and what do we do about the extra weight we can have with us. I think with
I know
CubeSats.
there's a number of future missions that are all vying for their spot and limited.
Well, there always are. Actually, that would be a good presentation for someone to do. Would be the decadal survey. It's what NASA uses every decade to talk about, to plan what they're gonna be exploring. And I'm hoping in my lifetime I see the decadal survey say Jupiter or Uranus and Neptune. Really hoping that happens.
But Bob, do you know? Have they started cutting metal for the thing? Do they, or is anything been built yet, or no?
I don't know.
Okay.
Find out.
Well, as long as you got people like Musk around, you're going to be able to do some of that because they're going to ask him to do the funding of that. That's almost assuredly.
I think they do some design work, but
yeah.
I don't know that they start making things
Well,
until
that's
really the funding.
The goal, there was
if it's government project, if it's NASA.
There's a couple of things that have been happening recently, and Bob alluded to. because there's been some terrific finds recently as far as the moons of Jupiter are concerned, is that they are extraordinarily water-bound. Callisto and Ganymede are supposed to be just loaded with it, a little bit deeper than Europa, apparently. And there is there. It looks like water is a lot of places. So we're and of course, if you get underneath, you get a little depth. You get some warmth from the core, and it gets warm enough to be actual water instead of ice. And that is, if there's enough chemicals in there, and there apparently is lots of carbon everywhere, and there's lots of things like that. So we could have evolved into simple life forms, and maybe even a little bit more complex and such. So it now becomes much more interesting to do. And they're even talking about some things that are possible on Titan, not necessarily the biological things that we know about, but they've got methane oceans, and we don't know what that's going to entail, or what the size of life things are going to be. So we're finding out that the solar system is extremely interesting in that respect. I'm not a great fan of human space travel, as you all know, but I am a great fan of robotic studies and doing that sort of thing, and discovering about the universe with that. I think that the money should be better spent that way. I think we can learn, if we advance our robotics to the point where they're capable of doing a lot more. And that would be taking some of the funding away from human travel. The problem with that concept, though, is people say, well, that's no fun. We want to go there, and regardless of the dangers and so on and so forth, the Congress has never been known as being very bright, in the scientific world. So
Well, one thing with human space flight, it seems the population gets, I don't know,
charged up.
well, they lose interest real fast. Like
Yeah, they do.
Apollo was like,
Of course,
okay,
yeah.
well, we already landed. Okay, what are we doing more missions for? What's
That's
the
right.
deal
Well,
with,
it was supposed to be.
12
It was
and
supposed to
13?
be. It was supposed to be an Apollo 20, and they stopped. Because of the funding, and people are very short. But again, I'm glad that they're not sending humans out
Yeah,
in
so
droves
like
anymore.
the first manned mission to Mars, everybody's up for. The second one is like, eh.
Yeah. Well, you're going to find out that first mission to Mars is going to be a lot more dangerous than they're concepting, because you have to understand now, you're going to have a 10-month trip there, and you're going to have to be there for 2 years just to get the orbit capability coming back. So that means you're going to have people that are going to be out there for 4 years, and you're going to have to supply them all their food, all of their air, all of their water, all of their medical supplies. You got to land those things. You got to store them, and that's just to Mars.
And if all of that
The radiation.
succeeds, they still have to try to prevent them from being overloaded with radiation there and back.
That's the big.
There.
That's the biggest thing. Coronal mass ejections. How are you going to protect them from coronal mass ejections? We went to the moon. We got lucky, really. If we get a coronal mass ejection at those people anytime while they're there, there's no magnetic fields. You're putting them at radiation risk, extreme radiation risk, and we haven't really figured that out yet. And we may, and I'm not saying that, in a couple of 100 years we probably could do a lot of things, but there's no reason to send humans. There isn't any reason.
For this Europa Clipper, would the huge radiation of Jupiter cause issues with the spacecraft, even robotic?
Absolutely. That's another problem. But the point is that the Juno is a tank.
There's 125 pounds of titanium planned for this
Exactly.
thing.
That's what you're talking about. You've got to, and the problem with that is you got to carry it there, that weight, and you got to do that for these humans that are going to have all their stuff with it. You got to protect the hell out of them just for Jupiter, if you talk about it. But you're talking about going to Jupiter. If you could double the speed, it's still going to take you 8 years to get there.
Now, if they were able to use the SLS, what was the time to get there? How much quicker?
5 months versus better part of what did they say? Hold on a second here. I got it.
6 years. Is it 5 months faster or 5 months total?
No, faster. I don't think
5 months faster if we went direct without the second flyby of Earth or whatever.
Right. But you have to,
Yeah,
you have to carry your fuel too. Remember that, for there and back. So what are we
I'm
talking?
talking this Europa thing.
Yeah.
Well, the Clipper.
Yeah. Well, the Clipper doesn't weigh that much. Really, seriously. Oh, the Clipper. That's It doesn't weigh that. We're not talking about. You take a rover that goes there. They're infinitesimally lighter than sending one human. With all this stuff, the concept is just vast.
So, in the 2001 space mission,
Okay, there it is.
2010,
what is it?
Was that obelisk it's orbiting Jupiter or orbiting a moon of Jupiter?
No, it's orbiting Jupiter. It's flying by.
Right.
Yeah, it's to orbit the
in the 2001 movie.
Oh, okay.
Space Odyssey. That black obelisk, was that orbiting Jupiter?
Yes.
Or a moon? I can't remember.
Yes, actually, the problem in the movie 2010.
Yeah.
Okay. They're coming into Jupiter, and they send a probe down to the moon, right?
Right.
Then they do the aerobraking procedure. That's totally opposite, because that probe, before doing the aerobraking, is still going at interplanetary speeds. So it's just going to go right by that moon. And
it's an impactor.
Yeah. So when you do the aerobraking, that brings you into orbit around Jupiter, and that's where you can start doing the flybys of the moons. But if you want to go in orbit around the moon, you've got to slow down a hell of a lot more, which means a lot more fuel.
There you go.
I haven't seen that movie in a long, long time.
So it says here that originally the SLS would have given a direct trajectory to Jupiter, taking less than 3 years, whereas the Falcon Heavy will take a longer 6 year, including 2 gravity assists.
There you go. I'll be right back.
So the SLS could have got it there quicker, but the SLS is expensive. Oh my God.
Are they still working the SLS?
Yep, they're planning on using it with Artemis, and they've dumped billions into developing that thing, and I'm sure a lot of good tech has come out of it. But when you've got reusable stuff like being reused 50 times now, I've seen people say, well, we gotta go with this, and even though the cost is like $2 billion per launch, it's we'll see what happens with the SLS. I'm taking a look at notes here. Then NASA was not even sure it would be available for the Artemis program. The cost to redesign Europa Clipper for the SLS's vibratory environment due to the solid rocket boosters was estimated at $1 billion. So they're not doing that. Yeah, I see here. See also Europa orbiter canceled by NASA because in order to go in orbit around Europa, you've not only got to do gravity assist to slow down and get an orbit around Jupiter, you've got to slow down again to get an orbit around the moon, like a lot. And then if you want to land, you got to slow down some more. Delta V is a great thing.
So with that extra 250 pounds, maybe they could have a secondary camera that they launch that sort of goes slower and follows them as they impact one of the moons when at the end of mission. Just say it's just our camera back to give us a close-up view, so we have those extra, 2 minutes of descent as it's crashing and a close-up view.
Some of
And
the
then it
ideas
also impacts.
Some of the ideas were nanosatellites, which could impact. Biosignature explorer, tomography probe, impactor probes. There you go. Flyby sample return. That would be cool.
Sample return?
Yeah, dust.
Not for
dust
250
sample.
pounds.
Yeah, I mean, my God. Unless it's an ion drive, and it'll return back in 2100. Oh, that's the problem with these planets out far. They take so long to get to.
All right, gang, 3-minute warning. I see Doug has his slide ready to fire up.
Yeah, I just have to make sure I unmute myself. You can hear me, right?
Yep.
Okay. I saw this little feature where I can put my video on the presentation, so you guys don't have to manually do that. Does that seem reasonable?
That's fine.
Is that a feature of WebEx? I haven't seen that before.
Yeah, when you go to share, there's a little checkbox near the top that says you want to put your video in front of your presentation.
Oh, neat.
Just turn it on.
So I don't have the weird background on mine. You see my cluttered room.
Mm-hmm.
Does yours only work if you have like the artificial background?
What do you mean? No, actually, it's not even displaying my artificial background in this mode. Yeah, the virtual background it doesn't come along with what I just turned on. It's just the video. In fact, it's interesting how that it's got it uses the presentation background as part of that video. But yeah, you can turn the virtual background on. There's a pull down on your video, and it allows you to select. There's defaults, and then you can add a photo of your own and say apply.
Yeah, but it chops stuff off. Because I'm in the dark. That's why. My room isn't lit.
Yeah, it's not a foolproof. Anyhow, but I just saw that this when it displays the video, it takes the background right away anyways. For both my back of my room or the virtual stuff, so it's pretty solid. It's either that or it's using the video as the background. Anyhow, I could make this smaller as a matter of fact, it looks like. Is that too small? I can make me as small as possible. Just don't want it to get in the way.
All right, 10 till. So, Doug, if you've got your text sorted, we're ready for Bob to take it from the top.
Alrighty. Well, welcome back, everyone. Doug Bock has been a member of the WAS since 1973, and he's a member of several other clubs. He has been the WAS's president, VP, and editor for our award-winning newsletter. He is chairman and vice chairman of the Great Lakes region of the Astronomical League in the early 80s. He's retired from Ford Motor Company at the end of 2018, and he's the owner and operator of the Northern Cross Observatory, where he has several telescopes and does astrophotography and live streaming. So take it away, Doug.
All right, thank you, Bob, and thank you for inviting me to give a presentation. Tonight's we're going to talk about astroimaging, mostly beginning, but I may move into some advanced examples as well if there's time, just to show you what the torturous journey is from beginning to end. So the agenda for tonight is showing you a simple setup, then a little more advanced setup, and some examples. And then a tracking system that you might want to put together for a little more longer exposures, and then some examples of that. And then one of the things you can do with this simple setup is take a lot of data and do things like time-lapse examples. And then I'm going to go over a couple of processing software that can be used to process the data that you collect. And then optionally, if there's time, we can go over some of the advanced systems that I've got as well. So that's what we've got going here. So to start with, a lot of people have, in the past at least, have had DSLRs. I know a lot of people now start using their digital phones for shooting through eyepieces and on their Dobbs and things like that, which is kind of a cool thing to do. But if you wanted to do some basic astro imaging, a very simple setup if you have a DSLR is you get yourself a tripod. And your digital camera, you mount that on your tripod on a ball mount. And you can take whatever set of lenses you may have. Let's say you have a 50 millimeter fixed lens. You could use that as a starting point if it's an existing lens. A lot of times when you buy these cameras, you can get camera kits that have zoom lenses like a 55 to 75 or a 28 to 55, a 55 or 75 to 300 millimeter, or even shorter as an option is a 10 to 28 millimeter lens. What I've did was most of my time lapse or my wide field stuff is I use either a 10 or an 18 millimeter lens setup for some of the stuff that you're going to see down the road. You're going to want to have what's called an intervalometer if you want to take lots of images over the night. Kind of
Say that word again.
Intervalometer. I'll show you an example of one. That allows you to.
And I'll type it in the chat.
Yeah. It allows you to set up a sequence of data where you can set the duration of the exposure, the pause between the exposure, and the number of exposures you want to take. Or you can just use the intervalometer, and I'll explain that for manual triggering of the camera. Another thing you're going to want to get is a dew heater, strap, and controller if you're going to do stuff all night long. You're going to want to have a power source of some sort for both the camera and the heaters. And the longer you go through the night, the more robust that power source has to be. I found that the camera batteries that came with my Canon T3i won't last more than a couple of hours if I'm taking continuous photos. So I end up buying a AC to DC adapter that allows me to power the camera through the night, as long as I have AC power, which I do have here at the house. You want to get a comfy chair, as you can see this picture. That's a nice observing chair. If you're going to sit out with the equipment and do your adjustments of ISO, exposure times, et cetera, you want to have something comfy you can sit on while you're doing that. Get your favorite beverage, and notice I have a coffee cup out there. And then the last thing you really need is clear skies. Now what you see here is there's a battery pack that I use. In this instance, I'm using to manage the heaters. And then the AC power cord coming from the observatory is to power the camera. So this happens to be a concrete pad I have in the backyard for other scopes to be set up on. So here's an intervalometer. This device allows you, again, set the exposure times you want, the pause between exposures, and the number of exposures. You can even set it so it just continuously takes exposures. But this button down here is a single press, allows you to trigger the camera, and you can hold it or lock it for a long period of time and then release it to take a single shot. And you'll find that you'll be using that quite a bit when you want to test things out. For example, if you're shooting the northern sky, you might want to try a different ISO setting, let's say 3200 or 6400. You want to take a 10 or 20 second shot there. You press that button and hold it, and then take a look on the screen as it pops up on the back of your camera to see if that's what you want.
Okay, to summarize,
Okay. So that's what that is. Somebody needs to mute themselves.
7775 will be charged $95.
Thank you. So dew heaters are an important part, especially here in Michigan, for all astronomical equipment that you may put outside at night. And this is an example where you have a dew strap, which you wrap around the end of the optics on the camera, and a controller. This just happens to be one of the controllers I've got. I've got 3 of them. This one has 4 ports, so I can run 4 straps, and it runs off a 12-volt DC power source. And you hook that on there, and you turn this to some, I usually run them at about medium. Keeps the optics clear of dew and or frost throughout the night. Now, the reason I have these is because I typically will take this camera setup that I just showed you, and I'll set it out there for the entire night, and I'll schedule up 15-second exposures or 20-second exposures with a 5 or 10-second pause at ISO anywhere from 1600 to 6400, because I'm going to create a lot of images for the purposes of stacking them, or maybe making a time lapse, which I'm going to demonstrate a time lapse video that I made from using just this kind of setup right here. The next more advanced is to have a computer involved, which allows you to run the camera remotely with the computer instead of the intervalometer. And what that also allows you to do is control all the aspects of the camera, the ISO settings, the exposure time. But there's several software tools you can use to run that camera. In this case, it would be a Canon EOS, which is a piece of software that run cameras, including the one I have, or a piece of software that I have called GB Time Lapse, which allows me to schedule up the entire night, including twilight, and it does nice gradually changes the exposure and the aperture gradually over time, so you get a nice transition from a blue twilight to the Milky Way coming out. It's one of the things that happens. It's kind of cool. You can do it also with like I said, with the laptop, and it usually is a USB cable from the computer to the Canon DSLR, and that's how you control it. Some cameras, though, have built-in Wi-Fi, so you could also do it that way without actually connecting a physical hardware. Just remember to make sure your dew heaters are on if you're going to leave it on all night, and enough power to power it all night. So I always use shore power or a generator. or a large capacity battery with inverters to make that job go well. So those are kind of the three options you may have. Shore power being your power at your cabin or the power at your house. And as you can see, there's this camera here. It's just got the little short, probably the 18mm lens on this particular example. And there's my laptop that runs it all. And I got batteries in this case here. I also got shore power. Now, the little more advanced you get, the more stuff you're going to have on your table. So you better bring a table then. Here I am with a iPad that shows me the sky software, or I'm running Sky Safari here to decide what area of the sky I want to center on. I have my laptop that runs this. I have the dew heaters, et cetera, and just cases that hold everything.
Yeah, well, this is the point at which I'm hoping I stop, but as we know, that never happens. But we'll see
Well,
if I
see, Adrian, I'm still doing this stuff though. I'm still doing time lapse and wide field stuff. As you know, I did that down at Okie Tex last October.
Yeah, and you did a really good
I'm gonna
wide
show you
field view.
Yeah, I'm going to show you a little bit of that.
Yeah.
So here's an example of taking just a single frame. This is with an 18mm lens, 15-second exposure at ISO 6400. And if you notice, there's the Hyades, which is part of Taurus. There's the Pleiades. And, you know, this is up in the northern part of the state, and actually at Bill Beers's place. This is the CW Sirius Observatory dome right there. As a matter of fact, at one of the star parties we did a few years ago. So this is kind of an example of a very simple single frame image that you could take with a wide field lens and your DSLR. Not too bad, right? Oops. Yeah. Here's another one taken at my place up north at Boone Hill. Single frame again with an 18mm lens, and it's 15-second exposure. And I've got a little bit of the Milky Way showing up here. I don't push the processing too hard on any of my images because they start to look cartoonish to me. So you can see though, there's the horse in the center of the core of the Milky Way. This is Scorpius right here, and I think this is Jupiter over here, and Sagittarius is up over here. There's the top of the teapot just behind the tree line. This is again at Boone many years ago with the 8-inch Dob that I have up there, and the 25-inch Dob is over here and kind of in the dark, but this is looking north. Again, another 18mm lens that's just 15 seconds, a single frame. Fairly simple. You can light up the foreground during the exposure like I did with the little red light here, so this stuff kind of pops out at you. So simple things that you can do with just a DSLR and tripod and a wide field lens. Here's another example. This one actually I created from a single frame that I created a time lapse of for that night over at Bill's place. This is the club's 22-inch sitting here, which Gary Ross used that night for his variable star work. This is Bill's CW Sirius Observatory, and we had a bunch of people up there. This is quite a while ago, probably about 6-8 years ago. Again, a single frame, but I took frames the whole night. And in fact, the video shows the scope moving around quite a bit. The scopes are running in the front here, and this guy tracking on the sky because this has got a motor on it. Again, this is a 18mm lens and 15-second exposure at probably ISO 3200 or 6400. Whoops, I guess I'm going the wrong way. Here we go. A couple of years ago, I picked up a new lens, a 10 to 18mm zoom lens, and I started taking 10mm wide field shots. And this is from the, I think the 2020 Great Lakes Stargaze up there in Gladwin, and when we had Johnny on a stick there. This John Lyons. But this is a wider field. This is Polaris right here. And here's the Milky Way coming through the Cassiopeia area, etc. And the Big Dipper's down here, gonna be sweeping down through here. And I've got a time lapse of this too. And then here's the little dipper here. I'm trying to visualize it myself. Hang on a second here. Should be right here. But again, a 15 or 20 second exposure. I think this one's 15 seconds with a 10 millimeter lens. So this is the kind of thing you can do again with just a tripod, little intervalometer. In fact, this is run with the intervalometer, and dew heaters and your DSLR. Now, when you get into really dark skies, like at Okie-Tex, this same setup allows you to do get a lot more data because the skies are so dark. This one is at ISO 1600, so it's not running as sensitive as maybe the ones I did here in Michigan with the 10 millimeter lens, and this is 20 seconds. Because it's a 10 millimeter lens, I can run longer exposures without getting star trails. It's what's called a 500 rule, and that is if you're using a full frame camera, you take 500 and divide it by the focal length of the lens, which case is 10 millimeters. And that gives you how long you go before perceptible star trails show up in the wide field itself, which means 500 or 50 seconds I could have gone, but I went 20 seconds. So you can see a little bit of star trail when you really zoom in on this image, but it's pretty negligible from a regular field of view like this. Lots of nice Milky Way here. Foreground of the Texas Okie-Tex. This is looking south. And then one of the options is you take lots of data, you can stack it and get some interesting results from that. This is a 15-second subs with an 18 millimeter lens, 17 frames stacked. This was back in 2014, I think it was, when I went down to Arizona. So this is down at the Apache Sitz-Grave Observatory, which Diane gave a talk on last time. And that's the kind of skies that we had out there. But again, it's really enhanced when you can stack this data and get some nice crisp information there. The next thing you can do is create star trails. Again, I took some 10 millimeter lens shots, 20-second subs at ISO 1600 down at Okie-Tex. I did it 2 nights in a row. The first night was looking south. The second night was looking north. This is 9 hours of data. So I collected for 9 hours of data, and you can kind of see quite a bit of rotation in there. Almost 50% of a day. If it had been 12 hours, it would have been just a little bigger arcs. But this was again the tripod setup. I had power, so I could run the camera and the dew heaters. Actually, I didn't even need the dew heater at Okie-Tex. It was so dry the whole time. Dew heater. In fact, every time I've gone south to the southwest to a star party down there, they look at those dew heater straps on my optics and they go, "What are those?" And I says, "Those are dew heater straps." "Why do you need those?" I says, "I live in Michigan. There's a reason you have to have them in Michigan. Yes, you may only have 10% humidity down here, so you don't need them. But up there at night, it usually gets to 70, 80, 90% humidity, even though it's clear." So they didn't know what dew straps looked like the first time I went down there 25 years ago. So this came out pretty neat. Again, 9 hours of data, which means I took about 1,500 frames, something on that order, well over 1,000 frames, and I put them in here. Using a tool called StarTrex to generate this star trails. StarTrex, I think, is what I used. Then again, doing the same thing, except this was with the again the 10 millimeter up at the Great Lakes Stargaze. Different processing, so it's a little brighter, but only about 6 hours of data, I think. Yeah, 6 hours at 15 seconds, and I think I was running at probably a higher ISO, 6400. So everything's quite a bit brighter. Again, the idea here is if you're going to collect data, why not collect it all night? You never know what you might find when you're doing something like that. An example would be you run it all night and you might pick up a meteor. And interesting, you might get a meteor and an aurora at the same time. This is from my backyard. Now this sky glow down here is a little bit of aurora, but that is actually Fenton. The Fenton sky glow north of me. But there is some aurora that kind of showed up there in this nice little meteor. So that's another thing that you could do if you are using your camera set up and you just let it run all night while you can be inside sleeping when you do this, right? Which I do often, by the way. I let my systems run all night. Or, you're taking images and suddenly an aurora pops up in your backyard or up north. This is up north, by the way. Actually, this is at Boone Hill. And you get some surprises when you set your time lapse up running for the whole night. Some aurora comes popping up. And this was an excellent one back in about 5-6 years ago, I think it was. And sometimes you get interesting aurora like that. This is looking to the northwest up at Boone Hill. Again, these are this was the 18 millimeter lens. These are 15-second exposures to gather that. And then this was over at Bill's place one trip that we went up there. I've got a whole time lapse of this aurora. This was a spectacular aurora. It was very, very, very bright and very interesting to watch. And moved this waveform just moved all over the place. But again, just a simple DSLR, an intervalometer to run it, and a power source on a tripod. If you have some telephoto lenses, you can do things like take a picture of the moon. I believe this is with my 300 millimeter lens. And the moon is so bright, your exposure is going to be really short, on the order of like 2/50th of a second or 1/500th of a second in order to get this kind of exposure. So again, something that astronomical you can do with just a DSLR, and if you have a longer focal length lens. The next thing up is using a tracking platform. This is my sky tracker that I got from Ioptron many years ago, and it allows me to put my camera on this ball head, and it has a drive system that runs at sidereal rate. When you set it up on a tripod, and you use the polar scope to align it to the North Celestial Pole. And there's a little app on my iPad that tells me where Polaris is relative, or where the North Celestial Pole is relative to Polaris on that date and that time at that longitude and latitude. So the camera can be up here with your 10 millimeter lens or 50 millimeter or 300 millimeter, whatever. Not too heavy. Got to make sure it's not too heavy because it doesn't have any counterweights. And then the ball mount allows you to move it around to point at any part of the sky you want. So that's a tracking platform. They've got much more sophisticated small platforms like this than when I bought this one. Some that have, from Ioptron, they have counterweights, and in fact, I've thought about upgrading to a small system like this as well for this type of work, as opposed to this. So I put a little bit heavier optics on the platform with a counterweight. But this allows me to take 1-minute exposures, which work out pretty nicely. And this is the application that tells you where to set Polaris. This little green arrow here, or green plus sign here, is where Polaris is supposed to be on that particular day and that particular time at this longitude and latitude. And so you just set it at that particular place in the polar scope, and this is what you see in the polar scope is this grid. So you set the Polaris there, and this is the North Celestial Pole. So now you know you're aligned pretty close. close enough. Let's see here. There are other applications as well that give you polar alignment. I'm sorry, go
You
ahead.
get that software you're showing on the screen right now.
You can just go online and look up Ioptron's polar alignment app. It runs on Apple platforms. But you can get other polar alignment. Pardon me?
You said Optron?
Ioptron.
Ioptron. Okay, I see now. Thank you.
Yeah, but you can also get other software that will tell you where Polaris is, and you can still use the same polar scope, as long as it's got a way of telling you where to place it within the grid. Even if the grid isn't exactly the same, you could still use other applications to determine where Polaris should be relative to that the location you're at and the time and date that you're at. You should be able to tell where the North Celestial Pole is based on that. So this just happens to be, and this was free, this software. One of the other things you can do with when you use a sky tracker, whether it's Ioptron or any other vendors, is you could take longer exposures and stack them together to produce some interesting work. Like, for example, this is a 75 millimeter lens on the Ioptron sky tracker, where I took 90-second subs and stacked them on the comet core itself. These are 9 frames to put together. And so the stars are trailed a little bit, but the core is not. So when you stack on the comet and the comet's moving relative over time, you're going to get star trails on the stars, but the comet will be relatively sharp, depending how well you stack the core in the software that you use. There's several pieces of software I'm going to go over, and I can explain a little bit of that. Another neat thing is to catch close apparitions of objects. Like here is an example where Venus was close to the Pleiades back a couple of years ago, and I stopped down the lens on this so that it make an interesting starburst, if you will, of the planet while it was next to the Pleiades. But again, you can use a tracking mount with a 300 millimeter lens to do this, and the reason you use the tracking mount is so that the stars are nice and round, and you can do longer exposures. If you did a 300 millimeter lens on a fixed mount, and your exposure gets to be a little long, you'll get streaking on the stars. So this was another example of using just your DSLR and probably or possibly the lenses you may have with you. Some of the pitfalls of doing this, though, is you get all kinds of artifacts on some of your optical systems or on your sensor or on the optics that are near the sensor. Things like vignetting or light leaks or dust donuts. As you can see here, I got a dust donut over here. And I've got vignetting over here. I got some type of light leak here. I got an obvious light leak here, which could be sensor glow, which from temperature. But here's the Horsehead, here's the Flame Nebula, and here's Orion Nebula in the Running Man here. And this is 14 by 1 minute subs. And I just wanted to give you an idea of some of the challenges that even with a DSLR and a tracking platform, with your lenses, that you need to be aware that there are other things that can go wrong. And so these are things that can go wrong. You don't have any flats, so these show up. And the flats also will take out some of these artifacts and the gradients that exist when you take an image. Now, when I said dust donuts, what that means is that there are particles of dust either on the sensor or on the window in front of the sensor that will generate different sized donuts. And so if either of those are not clean, they will show up in your image. Now, some of these artifacts can be mitigated, like I said, with darks and flats. Darks get rid of noise, flats get rid of all these gradients and various weird things, and I'll talk a little bit about that. But if everything goes well, you know, you can get a kind of a cool picture. This is 1 minute sub, 15 of them stacked. This is the North American Nebula with not much color in it, and I can't explain why I didn't color in this, other than the fact that I was running a DSLR when I did this. Whereas I've got another North American with my one-shot astrophotography camera. It's got lots of hydrogen red in this image. But this is something you can do again with a little simple tracker and a zoom lens, anywhere from 100 to 300 millimeter, depending on the object you want to frame it. This was 15 1-minute images stacked and processed. Here's another example with the T3i and the 300 millimeter lens. This is 24 by 5 minutes second, or 5 second, I'm sorry, 24 by 5 minute frames, piggybacked on a tracking platform, 2 hours of data. Now, the tracking platform here was not the Ioptron. It was actually one of my mounts. But the point being is that you can now mount your DSLR and any of your lenses on top of any mount and do longer exposures as long as that mount tracks well. And notice the dark lanes in this area. This is actually the area of the elephant trunk. Here's the area Antares. Now, you've probably seen some of the areas of Antares which show these colors very prominently. Very prominently. In my case, they're not so much because I tend not to push the color too much. But there's a lot of dark lane here and some bluish reflection nebula and a little bit of yellowish nebula here, etc. And if you ever see some really great pictures of Antares area, they're a lot better than these. But this was still, you know, you can call it your own. That's kind of the fun of it, is what can I do with what I've got? Now, the next thing you can do is you can make a time lapse. And what I'm going to do is just play this time lapse. This again was down at the Okie-Tex Star Party. I used my DSLR, my 10 millimeter lens, and I ran it all night. That star trail I made, that's from these images. So let's go ahead and run this and see what it looks like. Hopefully you can hear it. There's Orion, Canis Major. And then the next night I took it and pointed it north. Okay, so that's what you can do with the camera if you set it up for the entire night. Is you can stack some frames, you can do a time lapse, you know, lots of fun stuff that you can do with just those simple things. Again, that time lapse was done with just a tripod, DSLR, and a 10 millimeter lens. And I had the dew heaters on, even though I didn't need them. But that's the next thing you can do with that.
Yeah, in addition to bringing back memories, Doug, I just wanted to point out that you did that with modest equipment. There's a lot of equipment wars that might insist you need a certain type of DSLR, that certain things will look better, but getting started, it's just about having whatever you've got. And Doug, you've had that T3i for quite some time and still managed to take some brilliant images with it.
Yeah, I've had it 8 years. I got it in 2014, and I got it just before I took my trip to Arizona because I wanted to do time lapse or down there. In fact, I have a time lapse of my Arizona trip as well. I've got lots of time lapses. That just happens to be the latest one for all night at Okie-Tex that I took. So that's why I played that one, because it was last October. So anyways, I wanted to go a little bit over software that I use or for both acquisition and processing. So since I have a Canon EOS, I use Backyard EOS sometimes if I want to use a laptop to control it. I might use GP time lapse for data acquisition as well, and that particular application allows you to again start before sundown or before it gets dark, and it will take a snapshot of the current sky conditions, and then it will automatically change either the aperture and or the exposure and or the ISO rating as time goes through up to the maximum time you put in that you want it to take. So it might take like a 2/50th of a second just after sunset, and then it may take all the way up to the 20 seconds you want overnight, and then it just continuously does that, and then it gradually does the reverse at sunrise. So it makes kind of a nice transition where you got this blue sky and this Milky Way just kind of softly comes into view and as it gets darker. So it's a very cool tool for that. For stacking multiple frames, you can do it in PixInsight along with all of your processing in PixInsight, but I happen to use Deep Sky Stacker just for the stacking of the software or of the data, because it's really simple to do, and I'm going to go through that a little bit. And then PixInsight is what I use to process all my data, and I use a fairly simple process to do that. It's not elegant. It's I'm kind of one of these intermediate guys in terms of processing my data. Got a lot of guys that spend a lot more time than I do to process any set of images. I mean, if I take data on one particular night, I'm done processing within 15 to 30 minutes of the image, and I say that's pretty good. I use Vegas Studio to create my time-lapse videos, which is very useful because I can put pieces of various imaging videos that I've taken together, and I can put nomenclature on it, music, et cetera, and create an output that I put on my YouTube channel. So Vegas Studio is a very nice tool for me to use for that. If I'm going to do any cosmetic work, I may use GIMP 2. A lot of people have Photoshop. They'll use that, but GIMP 2 does what I need for that. In fact, before I was taking flats, I used to get rid of my dust donuts using GIMP, the clone tool, to get rid of a lot of my little dust donuts in some of my older images before I started taking the flats. And once in a while, I'll use a tool called Topaz AI Denoise. That doesn't work real well on all kinds of images, only on some. And actually, since I got the latest camera, I haven't had to use it much because that camera is really, really good. It doesn't have a lot of noise in it. So here's the example of the Deep Sky Stacker software. And I'm showing you this because this is what the stack will look like when it's done. It looks like caca, right? A green background, you hardly ever see anything. But this is a set of picture files, dark files, and flat files to make this image, okay? And when you do that, it just basically does an alignment of stars that are in the field of view on each frame, stacks it together, and creates one output file. It happens to be a TIFF file. Now, some people use this to do a little bit of processing. You can do color balancing and all kinds of stuff in here, but I don't bother because I use PixInsight to do my work. So I only want to spend a minute on that to show you what the raw data would look like after it's stacked. And now I want to show you what happens when you use PixInsight. That's the same data here. What you're seeing right here is my processing process, the process that I go through to get this file to look like that. One of the things I do is photometric color calibration. What that does is it takes the coordinates of the file that you've got. Again, this is more advanced. This is not DSLR work, but it can be used with your DSLR data. You can use these tools with your DSLR data. That's the reason I brought this up, is you can use both Deep Sky Stacker to stack images, and you can use a processing software. I just happen to use PixInsight, but people use Photoshop to process their data, or they use Lightroom or whatever, other things, maybe even GIMP. I just happen to use PixInsight. And this is the 4-step process that I always go through when I do my images. There are another half a dozen to a dozen tools that I may use in PixInsight, but this is basically it. I go through these 4 things. I might do a crop. I might do an unsharp mask to sharpen it up a little bit, but basically these 4 functions are what I do to generate an image like this. This one happens to be a little bit on the blue side because I pushed the blue channel a little bit too far. But what I will do is I'll show you, if you want to go a little more neutral with the colors, this is what it would look like this. This is with more neutral colors. The same data, just processed a little differently. And part of the exercise of using these processing tools is it becomes an art form at what you will or will not like. Okay, and each person likes it different, etc. So this is a little more neutral than the bluish background. It's got a little darker black background, but the colors are towards the yellow a little bit. The hardware, again, that I use for my simple setup is for all those previous images other than the Milky Way I just showed you. The DSLR camera is what was used. Various lenses are 10 to 18 millimeter, 18 to 55, 75 to 300, or my 300 prime lens. I use an Ioptron sky tracker, a sturdy tripod, and a power source, AC/DC for the camera, heaters, and tracker. This is very important that you have power for the entire night of acquisition if you're going to go all night. If you want to go a couple hours, you're probably good with your batteries that are in the camera. I just found that the batteries, especially when it gets colder, the batteries don't last as long. Now, that's the simple stuff. If there's an interest, I can go into a little bit of the advanced systems. Once you get out of the once you decide, oh, I've done all I want to do with the simple setup, there is some advanced system. And I'm going to ask Diane if it's okay if I move forward.
We do have time. So it's only 9:30. So, and you started at 10 till. So if you want to go into advanced systems, there is time. You know, you've got about 10 minutes.
Okay. Yeah, this won't take too long. This picture here is from one of the Great Lakes Stargaze events. I think it was the 2021 with my more advanced system. That's a 10-inch telescope on a fairly good-sized mount that I do a lot of my imaging with, along with astrophotography cameras as opposed to DSLR cameras. And I just wanted to go through a couple of things. If you're going to get more advanced, sometimes you get very strange ideas about building an observatory, which I did in 1984. In fact, I got so crazy about it, I moved out of Detroit out here to the country just because I wanted dark skies and was willing to drive 60 miles to work to have dark skies and raise my family here. So between 1984 and 2018, I had built this building in 84. This was back in 2017. I put the RC 10-inch in here. And then in 2018, I actually tore this building down to the floor and had a new one built because this guy was going to fall on me one day. My wife was afraid I'd die. So she says, go get a new one built. So we got a new one built. And that's what this is now. That's what I've got out in the backyard now. Again, this is kind of advanced stuff, you know, building a building. And the current options I have in that observatory are these setups here. This is the same 10-inch, both top and bottom, but this one's got the 4-inch SCT on it with a solar filter. This has got the 300 prime rem. This is the solar filter and the DSLR, which I can also mount the DSLR on top. Or I can put one of my astrophotography cameras on a 300 prime lens on top of the sky and take images while I'm taking images through the primary one, the main scope. I also have a 6-inch SCT that I can put on this mount and do solar work with a solar filter. That's what the article in the newsletter this month was, using this setup to take a couple of images of the sun recently. And last September, I picked up this refractor, which is the unit that I took to Okie-Tex, along with the cameras that I use. And it's right now, it's actually on the mount, and I've been using it quite a bit since the Okie-Tex Star Party in the observatory. So that's the 105 APO, and this is all the optics that I've got. And then I've got these cameras. I got a 071 MC Cool, which is version 1 of the 071. I've got a Pro version of the 071. I have a 2600 Pro, and then I have a Lodestar 2 for guiding, my Canon T3i, and a couple of security cameras, and then a pole master. And that little guy right there at the end of the mount there is my pole master for doing polar alignment. These are all on a Losmandy G11 mount. I have what's called an on-axis guiding port, not an off-axis, but an on-axis guiding port. And then I have an electronic focus. So this whole system, whichever setup I got out there, I can run from the house, so I don't have to sit in mosquitoes or in 5-degree temperatures. This is what I would call intermediate advanced, because the really advanced guys put lots more money into theirs than I do. I thought this was enough. So this is an example of what these astrophotography cameras look like. This is just one of them that I have. Nice APS-C size chip, pretty good size. They're cooled, the regulated temperature, which you want for astrophotography to keep the noise floor down. This is the electronic focuser system that I've got. This is a conceptual diagram of the setup. I have an observatory computer which runs the telescope through Ethernet. It runs the focuser through Ethernet. It runs all the cameras through USB, along with the pole master. I have Wi-Fi security cameras, so I can actually watch the scope when it's moving and make sure it doesn't do silly things. And then I have a Wi-Fi mesh network out to the house. And the house computer is the computer I'm sitting at right now talking to you. So I can run this thing remotely from the house. And these are the 3 tools that I use to do all that. SG Pro, PhD2. SG Pro controls all the systems. PhD2 does the auto tracking, auto guiding, and then Focus Lock does the autofocus. I can set up a script on this SG Pro and it'll run all night while I'm sleeping, collecting data. Here's an example with the refractor of the open cluster 2244, which is in the middle here, and then not the cocoon. Boy, I typed that wrong. This is the Rosette Nebula. I'm going to fix that. This is the cocoon. This is taken with the 10-inch. So we'll just show you some quick results here, and we'll be done with it. This was taken with the refractor. I'll answer the questions when we get done here.
I did have a question about that particular image. I think, wasn't this the one that you collected at Okie-Tex?
Yes, it was with the 4-inch refractor. Yep.
Yeah.
This came out a lot better than I expected, actually. This one I collected here at home. This was my 300 millimeter prime lens and the 2600 MC Pro camera. I love all the dark nebulas here, dark lanes. Of course, you've seen this one already. In fact, it was on the calendar. This is with the 105 at f5.6. I tried a focal reducer flattener, and I may put that back on again, except that I can't guide with it on. So. And this is the Pleiades. This was down at Okie-Tex with the 4-inch. This is one of my favorites, NGC 6946. It's called a Fireworks Galaxy. I've taken images of this several times over the last 5 years. I actually followed a supernova in this thing back in 2017. This is taken with the 105 refractor again, 5 hours of data of the Eastern Veil. Remember I showed you the Horset or the North American with a DSLR? Well, here it is with an actual astrophotography camera. Quite a bit different. It's with a 300 millimeter lens.
You can see the Pelican to the right in even more detail.
Yeah.
Really good shot of the Pelican.
Yeah, that is. That's nice.
This was down from Okie-Tex, one of my Iris Nebula shots. I've taken this
Holy
object.
moly.
I've taken several different times with this object. This time I decided to take 9.5 hours of data. These are 5-minute subs, 114 of them. And it was, I pushed it so you could see all the dark lanes and dark nebula. It's in this all over the place. Very cool. It does blow out the core when you push it this hard, but the idea here was what could I get in those dark skies? This is M66 in the Leo triplet. This was taken quite a while ago, I think in 2019 with my 10-inch. And let's see, 891, 3 hours of data for this one with my 071 camera. This is the NGC 7331 with the Deerlick group. All these little guys here are galaxies. This is 5 hours of data. The Whirlpool Galaxy, this one I was taking several years ago.
With a streak going through it.
Yeah, and this is before I realized I could use Signal or Sigma Clip, and it would have gotten rid of that. I might go back and process this data again, but I think it's also before I had flats. This is very recent. This is with my 105 refractor, 3 hours of data at Okie-Tex. M33. And one of the other good things I like to do, and I got a lot of these, is galaxy clusters. This happens to be Abell 2151. I wonder if any of you could guess how many galaxies are in this field of view before I show you.
1 million galaxies.
1,500.
Well, anyways, these are the ones that are identified with the plate solve out of Pix Insight.
That's not 1,500.
No, it's not. Well, this
It's
is
not quite 1 million either, but it's still
no,
a
it's
heck
not.
of a lot.
But it's a lot.
It is a lot. Wow.
Yep. And I think finally, again, I've got a 6-inch SET I just started using for solar work. So I've been,
Wow.
on February 8th and 9th, the 2 days in a row, I used my 6-inch to pull up these sunspots on the sun. And I actually published this in the newsletter as well. So I thought I'd just show that. This is just last week or last month. I actually have some more from.
Doug,
Yeah.
do you find working with the refractors gets better images? It seems to me they seem to be much crisper than the I'm talking of.
It's really. Oh, you mean on for the sun or for anything?
No, I'm talking about your shots of the stars and the systems and everything.
Okay, so
I thought the refractors were just stunning. You know, go ahead.
Yeah, well, think about it this way. My RC is running at 2,000 millimeter focal length, fairly high power. My refractor is only at 735 millimeter focal length. So the seeing condition will be more prominent on the 10-inch than it would be on the 4-inch.
Okay.
So if I got bad seeing, the 10-inch is going to pick that up a lot quicker than the 4-inch.
Got it.
And it's a lot more magnification, so your guiding has got to be more critical, etc. And I think if I was in Bortle 1 skies with great seeing, my 10-inch would outperform the 4-inch just fine.
Okay.
But in Michigan, we're lucky if we get better in 2 arc-second seeing, especially
Yeah.
when I'm taking 5-minute exposures. I mean, the seeing's going to be all over the place.
All right, I think we're firmly into the question phase now.
Yep.
Ooh, nice gallery. Who else has got some questions for Doug? Are there any in the any coming through on the YouTube stream?
Well, Bob has one. How much computer storage do you have?
Yeah, let's answer that one.
Okay. 22 terabytes.
That's a lot.
That's impressive.
I forget what the going rate for a terabyte is now, but I think we're at about 33. We're about $30 a terabyte right now if you buy storage. And Doug, you might be using a NAS or something.
Yeah,
Something
I'll tell you what I
aggregated
have.
storage.
I'll tell you specifically what I have. I have two 1 terabyte SSDs on this computer. I have a 6 terabyte hard drive on this computer. I have two 1 terabyte hard drives on this computer. I have an 8 terabyte USB hung onto this computer, and I have a 6 terabyte NAS in the other room.
And we've got a question from YouTube from David DeBello. So when you go to an event like Okitex, how many DSLRs are you taking along?
Oh, I'm only taking the one. Because when I go to Okitex, I'm taking 3 astrophotography cameras with me. The DSLR is only for that tripod. All the rest of my optical systems use my astrophotography cameras, which means it requires I have a computer hooked to them.
All right. Any other questions?
Let's see.
Doug, should we tell him? Should we resurrect the story of how we saved Okitex?
No, don't even go there. Don't even go there. That's an old one.
No,
funny.
I still am glad you were able to get the shots that you were, just as a result, because they were beautiful shots, and we had a few very good days. I will put in a plug for those of you that are listening and watching, and you haven't yet had a chance to go to Dark Skies. We highly recommend it. Just the whole nature of the sky changes with what you can see and what you can see visually. We're talking, Doug's been talking astrophotography here. There's a difference in what you can see visually the darker your skies go. So those of you getting into the hobby, definitely recommend seeing if you can get out there.
And Michigan has an increasing number of dark sky parks and dark sky
Yes.
sites right here. A tank of gas and a pair of binoculars is really all you need. You don't have to take the plunge
Exactly.
into a telescope. Just get yourself a GPS route on your phone and get in the car and head on out to Hudson Lake or Negwagon, Rockport, Port Crescent. There's a lot of amazing underutilized places here in Michigan.
And a tank of gas will cost you more than your binoculars.
Yeah, I mean, the trip out to Okitex last October, because I pulled a 7,000-pound trailer and all of our equipment, it cost about $1,000 round trip, and that's back when it was around $3 a gallon. So the trip but I had budgeted for it. I knew what it was going to cost us. And really, most of my trips are just to my property up north in the west of Cadillac. I go up there, and it's only 170 miles. Somebody asked from YouTube, how much money have I spent on the hobby? Well, that varies depending on what decade it was. I didn't spend a lot of money on this hobby until I put this last imaging system together in the observatory I just showed you. That was the big chunk of money, is all that equipment. These astrophotography cameras that I've got, the 3 primaries, are around $1,500 a piece. 2 of them, and then the other one was $2,000. But the prices have gone up. I noticed the 2,600 now is about $2,400. That's just for the 3 cameras, and then the scopes. The scopes are going to be whatever you want to get. They can be a 10-inch Newtonian f4 that's $600, or you can be a Takahashi for many thousands of dollars. So that's kind of that's a different bailiwick as far as how much scopes are cost. But the cameras, you can't, if you want a decent sized camera, you're going to pay a few bucks for it.
All right. Well, we have hit the hour mark. Thank you very much, Doug, for hopefully making astrophotography a little more accessible. And thank you for everybody for participating with questions. Wish we could all hang out at the Redco, but not this month. So with that, I'll bid y'all good night. And remember the way the calendar falls, we have our virtual Macomb meeting next Thursday. See y'all.
Take care, all. Good health.
Good night.
Bye. Good night.
Hey, everyone.
Great presentation, Doug, and a lot of memory lane, going back down memory lane, seeing some of those images we put up. I ended up getting one of the Orion/Milky Way images. Explore Scientific has a magazine called Skies Up, and they featured that image on one of their front covers for an online magazine. So it was I was pretty happy about that.
Anon, you're still there. Oh, I'm going to ask. I got a couple of private messages from him. Let me see if I can answer those.
Is there echo, by the way?
No.
For coming from me?
No.
Good.
No, Anon, I don't plan on using anybody else's equipment down in Arizona or Chile for my imaging. That's the reason I bought it all. And the reason I'm doing that is it's cheaper for me to own my own than it is to buy time, especially for the 1,000 hours of data acquisition I've done in the last 5 years. I would have spent a fortune using remote systems in other parts of the world. And I spend a lot less money buying my own stuff and using it when I want. So that's why I did that. The price per hour was a lot cheap. Actually continues to go down as I use my equipment. Let's see here. Shooting stars, yeah, that's just you just open up the camera for 15 seconds and continually do that. Once in a while you'll get a meteor. I've taken 1,500 frames and only gotten 13 meteors out of the whole night. So it really depends on how active they are. Okay, I'm gonna take off.